Good afternoon, everyone. Today we're going to do a video on logarithmic differentiation. This would be in the grade 12 calculus curriculum towards the middle of the year. And so we're going to look at two different examples and kind of talk about when it's beneficial to use this strategy rather than the more traditional way of differentiating functions. Okay. So one type of function that is often best suited for the logarithmic differentiation are exponential functions. And that means any function that has a variable inside an exponent, okay? So for our first function, we have y is equal to cos of x to the power of 2x, okay? Now I'll remind you of some basic log rules that are gonna make our lives a bit easier. First, we have that the ln of a to the power of x is equal to x times the ln of a, okay? And then we have that the derivative of the ln of x is simply 1 over x. I'm sure you've seen already, okay? So the first thing we're gonna do for this kind of function is we're going to take the ln of both sides. So we'll have that the ln of y is equal to the ln of cos x. And now rather than writing to the power of 2x, we can apply rule number 1 and have the exponent come out front. And so we'll have 2x times the ln of cos of x, okay? Now that we have the ln of both sides, we're ready to differentiate both sides. And so I'll even write that on the side. Differentiate at this step. Now, on the left side, we're differentiating y. And so remembering your implicit differentiation rules, we're going to have the ln of y differentiated becomes similarly 1 over y, but we can't forget to tack on our dy dx. This is really our answer in the end, and so we can't forget about it, okay? We're going to be lost without it. On the other side, we're going to apply the product rule because we have 2x that acts as a function and we have the ln of cos of x that acts as a function. And so the derivative of 2x is just 2, and so the product rule will give us 2 times the ln of cos of x for our first term. And then the second part will be plus 2x times 1 over cos x, but we can't forget to multiply by the derivative of cos x. And the derivative of cos x, if you remember your trig functions, is negative sine x, okay? Now let's clean this up a bit. So we'll have 1 over y dy dx is equal to, on the right side, we can leave the first term as it is. There's not much to simplify in this one. Now the second one, we're gonna have a negative, so rather than having plus a negative term, let's subtract instead. And if we multiply through, we'll have a sine x over cos x. Now, if you remember, that's one of your fundamental trig functions. Sine x over cos x is exactly tan x. And so let's write that out as minus 2x times that tan x, okay? And now we're almost done, but we have this y in the denominator on the left side. Whereas we really want dy dx to be isolated, let's get rid of this y on the bottom. And to do so, no differently than we would with x, let's multiply both sides by y, so as to cancel out the y in the denominator, and we'll multiply the entire right side by y as well. And so now, we'll finish up with dy dx is equal to, now we have an expression for y. Rather than just leaving it as y, we can write y in terms of x, thanks to our original function. And so we'll have cos of x to the power of 2x times what we have here. So times 2 times the ln of the cos of x minus 2 times x times tan x. And here is our solution, okay? Now this would have been very difficult to do using traditional differentiation, but with logarithmic differentiation, just using a few convenient rules at the start, you see how easy it makes our lives. This is really not that bad of a solution, okay? Now, on the other side, this would be more suited for traditional differentiation. However, I think that there's a strong argument to be made that logarithmic will also make it pretty quick and easy to do, okay? It'll be more efficient. And so, likewise, we're going to establish a few rules at the very start. So, first off, I'll remind you that ln of a over b can be written as the difference of ln of a minus ln of b. This would be great kind of your level math when you first learn these rules. And so, similarly to what we did in example 1, we're going to take the ln of both sides, okay? So we'll have the ln of y is equal to, and then using that rule, let's write this as simple as we can from the very get-go. So we'll have the ln of this entire right side that can be written as the ln of x cubed, and then again, applying this rule, the ln of x cubed is really 3 times the ln of x. And so let's write it as such. And then minus, since these two functions are on the bottom, sorry, there should be another bracket here. Since these two functions are at the bottom, they serve as the b in this rule, and so we're going to subtract them, okay? And so we'll have minus the ln of the first part, 3x minus 1, and then similarly minus the ln of the square root of x squared plus 3. However, I'll remind you that the square root acts as an exponent of 1/2, and so using again the rule over here, we can have the 1/2 become our coefficient, and so we'll have minus 1/2 the ln of x squared plus 3. Okay, now putting it all together, now it's time to differentiate both sides. And so on the left side, we'll have, as always, 1 over y times our sought after dy dx. And on the right side, 3 times the ln of x simplifies down to simply 3 times 1 over x. When we differentiate, right, the derivative of ln of x is simply 1 over x, and the 3 is a constant term, so we just pop it up front. Next, we'll have minus 1 over 3x minus 1 times the derivative of 3x minus 1, which is just 3. And then finally, we'll have 1 over, the 2 can combine with the x squared plus 3, but we can't forget to multiply by the derivative of x squared plus 3 by the chain rule, and so we'll multiply by 2x. Okay, and now we're almost done. We have 1 over y dy dx is equal to 3 over x minus 3 over 3x minus 1 minus the 2 on the bottom and the 2 on the top. Those can cancel out, and so we'll have x over x squared plus 3. And now, like we did in example 1, we have to take care of that y on the bottom, and so we'll multiply by y on both sides, and reminding that y has an expression, right? So the y's will cancel out on the left side, and we'll get our desired result of just dy dx, which is what we're looking for after all. And on the right side, let's write y out first, because we're multiplying the entire thing by y, so we have to bring it back in at the end. So we'll have x cubed over 3x minus 1 times the square root of x squared plus 3 multiplied by all of this that we found through differentiating. So 3 over x minus 3 over 3x minus 1 minus x over x squared plus 3. And here is our derivative. And so that's our final result. Again, not too terrible. As far as how messy the function looked at the very beginning, 4 lines of work is not too terrible. So again, these rules are going to be worth kind of committing to memory as you go through these sections. And I really hope this helps. And if you guys have any questions, comments, suggestions, and always suggestions for future videos, please leave a comment down below. And thank you so much for watching.